Hello friends, welcome back to Pharma-info. Today's topic is synthesis of furosemide, right? Now what is furosemide, right? This particular compound is acting as an antihypertensive, right? Okay, antihypertensive. We all know that hypertension is a disorder which can be treated with various category of drugs, right? So several category of drugs are involved, right? Pharmacological category of drugs which are involved in treating hypertension. One of the categories is found to be what? Diuretics, right? Diuretics. And this is the drug which falls under the category of diuretics. To be more precise, loop diuretics, right? So, and we all know that diuretics are those agents which just which are acting on kidney and thereby, you know, they are just reducing the plasma volume, right, and thus making the pressure normal, right? Chalo. So this is all about your the pharmacological things and all. Furosemide, it belongs to the pharmacological category of loop diuretics, right? Loop diuretics helps in reducing what? The hypertension, right? Chalo. This is found to be the primary application of furosemide, right? Chalo. Now, the topic is synthesis. So let us just, you know, shift our attention from pharmacology to medicinal chemistry, right? Synthesis. Now before starting the synthesis, right, we should see how it looks actually. Okay, let us just know the building first. Okay, let us know the just blueprint of that building, right? So furosemide, what are the information that can be fetched from the name? Name is, if we just try to split this in two different fragments, right? One is furo, and if we just try to manipulate this term, right, we can get like furan, right? And semide means sulfonamide. So these are the two informations, okay, that can be fetched from the name itself, right? So one is furan, the other one is sulfonamide. Let us just draw the structure of furan first. So this is your furan, right? And apart, in addition to this, you just keep it in your mind that furosemide is the one which is also holding an acid called anthranilic acid, right? Anthranilic acid, right? So if we just try to draw the structure of anthranilic acid, this is something like this. This is anthranilic acid, right? And we need to connect this amino of anthranilic acid with this furan, right, by means of a methylene bridge, right? So by means of a methylene bridge, that means CH to NH, right? CH to NH. Okay. If we just try to figure it out chemically, it is something like this. CH to NH, right? What are the other things that is also there? Sulfamoil, that means sulfonol. Where exactly it is attached? 1, 2, 3, 4, 5. It is the position 5 that is holding what? Sulfamoil group, right? And one more halogen is there, right? But don't get confused with the name. The name suggests fluorine, but actually the halogen is chlorine, right? Chalo. So this is all about the structure of furosemide, right? With that we have just developed the structure of furosemide, right? So from the name itself, we got two informations pertaining to its structural features and all. One is your furan, the other one is sulfonamide. So this is 2-furan actually, 2-furan, or we can say up to this is furfuryl, right? Furfuryl, right? Chalo. So this is 2-furan connected, which is having a CH2, right? Which is linked to this amino of what? Anthranilic acid. To that anthranilic acid, position 4 is having chloro and position 5 is having a sulfamoil, right? Thus we are done with the structure of what? The furosemide, right? Now let us see the IUPAC naming and all, right? Okay, IUPAC naming. It's very simple, right? Anthranilic acid, you are not supposed to use the term anthranilic acid while, you know, framing the IUPAC. Rather, we should say it's a benzoic acid, right? Because it's a, we can say benzoic acid, anthranilic acid is found to be an analog of benzoic acid, right? So this is benzoic acid. With that we got what? With that we got the parent system, right? So this is found to be the parent, right? If this is parent, let us just deal with let us just indicate the substituents. What are the locations? It is the position 2, it is the position 4, and it is position 5, right? Okay. So this is what? This is basically, this can be called as sulfamoil, or this can also be called as aminosulfonyl. So A comes first, that means we need to place it at the very beginning. So 5 aminosulfonyl, right? Sulfonyl, right? Then comes C, that is chloro. So likewise 4-chloro. Then the major one, right? The major one is nothing but what? Furan acting as a substituent. So this is furan 2-yle or 2-furanil, anything, right? So furan or 2-furanil methyl amino, right? So this is basically furanil or furan 2-yle methyl amino, right? Okay, chalo. So this is about here. So now accordingly we have to write 2 within bracket 2-furanil methyl amino, right? So this is found to be the substituent which is placed at this location, right? So likewise we can just say like this. This can be written like this, right? Okay. So this is the thing, that means 2 of what? 2 is holding what? Amino, right? So 2 is holding amino, right? So let us do one thing. Let me just place it here, right? Chalo. So 2 means position 2, holding what? Amino. Chalo, amino. Amino is holding what? 2-furanil methyl, right? Or furan 2-yle methyl, anything, right? Because it is the second position of furan which is connected to this methyl. And methylene here is acting as a substituent, that means methyl only. So like, and once we are done with the substituent and all, then straightway benzoic acid. So first position 5, finish position 4, come to the position 2, deal with the things which are kept at position 2, right? And then finally benzoic acid. So this is how the nomenclature stands, right? Now let us straightway move to the synthetic way by which furosemide can be developed or made, right? Chalo. So now this is your furosemide. So let me, in that very process, we have to just see how it looks. Okay, once more, right? So we have a methylene here, which is connected to the nitrogen of anthranilic acid. So on top of it, you have to put the COH because they are ortho to each other, right? At position 5 with respect to the carboxylic, we have a amino sulfonyl or sulfamoyl, right? And next to it, we have a chloro, right? So this is how it stands actually. So now where we should start? Okay, where we should start, or we should start with what, right? Chalo. So now this is the thing that is found to be the choice, because we know that how this sulfamoyl can be inserted into a benzene nucleus, right? And as it is amino, right? So preferentially, if we just put here chloro and introduce amino, introduce an amine in the environment, what this amine will do? Amine will release one of its hydrogen that will react with this chloro. They will leaving behind what? The amino function, right? Chalo. तो उसी के चलते we got the first or the primary reagent. What is that actually? If we just try to figure it out how it looks actually. So this is your benzoic acid, right? To that benzoic acid we have to place one chloro here. For what? Because we need to insert the amino here. So it's better to keep one halogen here, right? We have a chloro here, and here let us just remain. Let us just keep this area, unsubstituted, right? So now, what is the process that is quite often been opted in order to introduce what? Sulfamoyl. So it's a stepwise process. First, we need to add what? SO2 in the form of SO2Cl, and from where SO2Cl will come? From chlorosulfonic acid, the SO2Cl will come. So HOS double bond O Cl, right? So what will happen initially when they will interact? What will happen? The hydrogen is there, so both will leave in the form of, so both can contribute, okay, in making water molecule. So dehydration took place, and it is the dehydration that eventually leads to the production of what? That eventually leads to the production of another analog of benzoic acid like this. So it's a sulfonyl chloride, right? Sulfonyl chloride. Chalo. So our chlorosulfonyl. So this is 2, this is 4, 2,4 dichloro, then 5 chlorosulfonyl, then benzoic acid, right? So this is found to be the intermediate one, right? Chalo, intermediate one. What this intermediate one will do? We need to treat this intermediate one with ammonia. Why? Because we have to make this not chlorosulfonyl, rather aminosulfonyl. In that very process, so the ideal reagent will be like this. So chloro here, and accordingly we have to put here chloro, and this has become now converted to SO2 NH2, right? Chalo, fine. So now what next? We are just at the fag end of this particular synthesis, right? We got intermediate 2, right? Now let's see that how this intermediate 2 will behave with another reagent, right? And the reagent should be, because we are left with what? We are left with this portion, right? CH2NH2. And intentionally we have kept, or we have made this area what? Halogenated, right? Why? Because we are going to introduce amine, right? And this amine will liberate one of its hydrogen, and that will be caught by this chloro, right? Because chloro is acting as a leaving group, right? So what will happen? Leaving behind what? The NaCH2, right? So this is found to be the final reagent, right? With which we may get our compound of interest, that is your CH2NH2. So this is nothing but furfuryl amine or furfuryl amine, right? Furfuryl amine, you have to introduce heat as well, and an inert solvent, that is diglyme. Diglyme should be the inert solvent that is quite often being introduced, right, along with this furfuryl amine, right? Chalo. So what will happen? Finally, we can get our compound of interest, that is furosemide, right? So how it looks actually? So this is CH2, we have a NH, right? This is the NH, which is the part and parcel of what? Anthranilic acid. And here we have a sulfamoyl like this, and we have one more chloro here. So thus we got what? Thus we got our compound of interest, that is furosemide. So we got furosemide in this way, in this fashion, right? Now let us just brush it up once more, right? So initially what we did actually, we have taken the benzoic acid along that means dihalogenated benzoic acid, right? And what at the very beginning what we did, we have introduced chlorsulphonic acid. So it is upon dehydration, what happened? The chlorosulphonyl got attached here, that is at position 5 of this benzoic acid. Now this intermediate one reacted with ammonia, right, to form sulfamoyl or aminosulphonyl. Once we got the intermediate 2, we are at the penultimate step, right? So suddenly this intermediate 2 will react with what? Furfuryl amine or furfuryl amine in presence of heat, and the solvent that we are taking here is diglyme, right? And once they interact with each other, what will happen? There is a formation of our compound of interest, that is loop diuretic, preferentially given to the patient who is suffering from acute hypertensive crisis, right? Chalo. So this is how we got furosemide. So hope you have enjoyed the session. You have understood the fact and file which has been kept here, right, in making furosemide. So if you like this video, don't forget to press the like button, right? And please do subscribe my channel so that both of us can grow, right? Both of us can grow. Thank you for your patience hearing. Thank you.